Greetings and welcome to the Introduction to Astronomy. In this episode of New Discoveries in Astronomy, we will talk about how scientists discovered evidence of an ancient stellar explosion preserved in Antarctic ice. So let's get started. Can Earth preserve evidence of an event that happened between the stars? At first glance, that might seem impossible. But deep within Antarctic ice, scientists have discovered tiny traces of a rare radioactive element that may reveal the history of an ancient stellar explosion. The discovery does not come from a telescope image. It comes from atoms trapped inside ice that formed tens of thousands of years ago. And those atoms may be helping astronomers reconstruct the history of our local galactic environment. The key to this discovery is a radioactive isotope known as iron-60. Iron-60 is not commonly produced on Earth. Instead, it forms deep inside massive stars and is released into space when those stars explode as supernovae. That makes iron-60 a valuable cosmic fingerprint. If scientists find iron-60 in geological materials, they know that somewhere in the past, the material from a stellar explosion must have reached Earth. Previous studies had already detected iron-60 in ocean sediments and younger Antarctic snow, but researchers still needed stronger evidence to identify its source. Scientists analyzed Antarctic ice dating from roughly 40,000 to 80,000 years ago. To find the iron-60, they began with nearly 300 kilograms of ice. After extensive processing, only a tiny amount of dust remained. Researchers used highly sensitive instruments capable of identifying just a handful of iron-60 atoms among the trillions of ordinary atoms. This process has been compared to finding a single needle hidden inside tens of thousands of football stadiums filled with hay. And yet astronomers successfully detected the isotope. That detection became the critical clue. The discovery pointed toward an unexpected conclusion. Astronomers believe that our solar system is currently moving through a region known as the local interstellar cloud. This cloud is a vast collection of gas and dust between the stars surrounding our solar system. The presence of iron-60 suggests that this cloud contains material from an ancient supernova explosion. In other words, the cloud surrounding our solar system may be part of the debris left behind by a long-ago stellar explosion. As the Earth moves through this environment, tiny amounts of that material continue to reach our planet. This study is important because it links Earth directly to events that occurred far beyond our solar system. Scientists are not observing the original supernova. That explosion happened long ago and is gone. Instead, they are studying material that survived the event and remained preserved for millions of years. The iron-60 itself acts as a historical record. By tracing where it came from, researchers can learn how our local interstellar environment formed and evolved. Future studies of even older cores may reveal an even clearer picture of how our solar system traveled through the galaxy over time. This discovery reminds us that the history of the universe is not recorded only in light. Sometimes it is preserved in the matter itself. A few radioactive atoms trapped in Antarctic ice become evidence of an exploding star that vanished long ago. And by learning how to read those clues, scientists can reconstruct events that shaped our cosmic neighborhood long before humans ever looked toward the sky. So that concludes our discussion on supernova debris frozen in Antarctic ice. We'll be back again next week for another episode of New Discoveries in Astronomy. So until then, have a great day, everyone, and I will see you in class.